In this video, we are going to go through a couple of different things. We are going to need our periodic tables. So we're going to talk a little bit more about electron configurations, which we already spoke about in the previous video. We're also going to talk about valence electrons and then electron dot diagrams. So as we talked about in our last video, electron configurations are the distribution of electrons based upon the Bohr model. So it tells you how many electrons are in each shell, and it is listed on our periodic table right below the atomic number. Now, there are some occupancy rules for electron configurations. The why as to these rules hold is something that we will get into more if you take AP chemistry. For now, you'll have to kind of take my word for it that I'm not lying to you. The first level can only hold 2 electrons. Second level can hold 8. Third can hold 18. The fourth and fifth levels can each hold 32. Then it starts decreasing. So 6 is back to 18, 7th is back to 8. So you just need to know that they can each hold a certain amount, and you can use the electron configurations that are on your periodic table to help you remember this. What we do want to know is this last rule here: no more than 8 electrons are in the outermost principal energy level. All right, for example, if we take a look at calcium on the periodic table, calcium's electron configuration is 2882. So some information that we can gather from that is calcium has 4 electron shells, so 4 rings around the nucleus. It has 2 valence electrons. Valence electrons are the outermost electrons. 18 kernel electrons, those are our inner electrons, and 20 electrons total, so that adds up to 20. The first and the second shells are completely full at their maximum capacity, and third and fourth do still have some room in them. So all we are doing here is just copying down the electron configurations from the periodic table. So we find carbon, atomic number 6. Its electron configuration is 2, 4. So that means it has 2 electron shells. Cesium you'll find over on the left-hand side, atomic number 55. That is 2, 8, 18, 18, 8, 1. So that's going to be a bigger atom. It's got more electron shells. And then iodine, back over to the right side of the periodic table, atomic number 53. It's 2, 8, 18, 18, 7. All right, valence electrons. This is an important vocab word, and this actually already showed up on one of our previous slides in this video. So valence electrons are the outermost electrons. So when we looked at iodine's electron configuration, the last number in the electron configuration was 7, so iodine has 7 valence electrons. When we looked at cesium, its last number in the electron configuration was 1, so cesium has 1 valence electron. The reason why we care so much about valence electrons is since they're the ones on the outside, they're the ones that will involve themselves in reactions. They will be gained, lost, shared to form different compounds. So they will give an atom its properties. So valence electrons are very important in determining the properties of the electron or of the atom. Since they are the ones on the outside, those are the ones that are involved in the reaction. So we just look up the electron configuration and it's the last number. Then a different vocabulary word, kernel electrons, that's everything that's on the inside. So valence is the last number, everything else is a kernel electron. So for example, if we take a look at bromine, bromine's electron configuration is 2, 8, 18, 7. So 7 valence electrons, because last number is 7. And then everything else would be kernel, so that would have 28 kernel electrons. So the kernel electrons basically give an atom some bulk, but the valence electrons are the ones that really determine the dot diagrams or dot symbols or Lewis dot diagrams. We will put the symbol and then use dots to represent the valence electrons. We will use this a lot when we do bonding because, again, it's those valence electrons that are bonding and being involved in the reactions. All right, so what we have to do here is first look up the element and see how many valence electrons it has. So we go to our periodic table, we find potassium. Potassium's electron configuration is 2881. So it has 1 valence electron. So all we do is we write a K with 1 dot for the 1 valence electron. And it does not matter which one of those 4 sides you put the dot on. Okay, same thing for calcium. We look at the periodic table, we find calcium, it's right next to potassium. Calcium's electron configuration is 2882. So calcium has 2 valence electrons. So we do 2 dots. Now you are supposed to do 1 dot per side, then start doubling up if necessary, if it has more than 4. So you should put them on different sides. Now it doesn't matter if you do top and bottom, right and left, top and right, top and left, whatever, as long as there's 2 dots there. Okay, next one, sulfur. So we go to the periodic table, we find sulfur. Sulfur's electron configuration is 286. So sulfur has 6 valence electrons. So we draw 6 dots. 1, 2, 3, 4. Then we go back and double up. So 2 of the sides will show 2 dots. So 2 of the sides will show 2 dots. 2 of the sides will show 1 dot for a total of 6 dots since sulfur has 6 valence electrons. Next up, we have argon. Argon, atomic number 18, has 8 valence electrons. So argon will have 2 dots per each side for a total of 8 dots because it has 8 valence electrons. Okay, last 2 examples are ions. So for ions, what we have to do is we have to think about how many valence electrons it starts with, think about if it's gaining or losing, and then additionally, we have to use square brackets. So for example, the calcium atom, so not with a charge, calcium atom has 2 valence electrons, so it would have 2 dots. Calcium with a +2 charge means it has lost 2 electrons. So you are going to draw no valence electrons because it lost 2 electrons, square brackets because it's a charge, and then put the charge on the outside. Okay, number 5. Sulfur with a -2 charge. So first we had to think about regular sulfur, and you could do this part in your head, or you can write it down. Regular sulfur, so the sulfur atom has 6 valence electrons. -2 means it has gained 2 electrons. So now it would have 8 valence electrons. So we draw 8 valence electrons. Then, since it's an ion, we will have to use the square brackets because that's the way that we show the ions, and then charge on the outside.